So, guten Mittag, good afternoon. My name is Maarten Mulders. I'm here to talk with you about React. And we have 40 minutes, which is not quite a lot of time to discuss React. So I would like to ask you if you have any questions, please keep them for the end, where we have some time to discuss the questions. And I will be having an eye on the chat to see what kind of questions you have. As I said, my name is Maarten Mulders. I work with a Dutch consultancy company called Info Support. We do like exciting technology, technology that we consider awesome sauce. And React is definitely a piece of interesting technology. I'm going to share my screen with you, and then we can get started. So, as I said, React in 40 minutes. That's pretty, well, challenging. Let's get started. What is React? React is a library developed by Facebook originally, but then open sourced to the community, which allows you to build user interfaces. And the way they do that is by providing you with a way to do that in a declarative way. That's a very important thing to remember already. Everything in React is declarative. You focus on what you want to have rather than on how to achieve that exactly. And you do that in React using JavaScript, and optionally you can use XML. If you've ever seen a bit about React, you will know, you will probably have seen some XML or HTML like stuff. Well, we're going to dive in today what that actually is and how it works. So, how does React compare to other contestants in the field? The first and very important difference is that React does not provide you with two-way data binding. So everything in React is one way. It works one way, which is top to bottom, and there's not a way to go back. That may sound odd, especially if you're used to frameworks that let you do that, but we will see that it's actually very convenient, and it makes it very easy to reason about what your application will do and how it will behave. React does not offer you a templating language, which is the second interesting difference. The JSX that we will discuss in a few minutes does look like a templating language, but it is not. So you don't need to learn a new language and how to use it. You can use existing technologies that you probably already know of. Third thing is that React offers you only a way to do the user interface, and everything else is not in the box. Again, that's quite a difference with some of its contestants that provide you a full toolkit for everything you will ever need to build your web applications. React chooses to focus on only that one thing. That means that if you want to add stuff that is not in the box, you will need to find a different tool to do that, which lets you basically mix and match as you see fit. React lets you write your applications in plain JavaScript. The use of JSX or TypeScript is optional. I would highly recommend, by the way, doing TypeScript, especially for larger applications, but it's not required. You can do without. And another distinguishing feature of React is the use of a virtual DOM, a virtual document object model. And the changes to the actual document object model are delegated to the runtime. So you don't need to be aware of the document object model. Before we dive into React, I would like to recap a little bit on what JavaScript looks like nowadays. If you're like me, you have probably been developing front-end applications for your APIs for quite a couple of years already. But JavaScript has caught up as a language. I mean, you can do a lot of things with JavaScript nowadays that weren't possible in the past. So the first thing I want to show you is the use of classes in JavaScript. This is a live coding environment, so I can just start coding here, and you will see immediately what the effect is. The first thing is that we have classes in JavaScript. Classes behave basically as you would expect from a Java background. You can instantiate them, you can invoke methods on them. They have instance variables, everything that you would like to see. And as you can see, you can invoke that method, and it works perfectly fine. Well, okay, great. How about functions? Well, the first and most basic way to declare a function in JavaScript is this way that we probably all have seen. You can invoke the function saying is even number 4, and that's true, of course. But you can also write your function as an arrow function, which is a little more compact. We still see the argument of the function and we see the implementation, but the keyword function is gone. And here we can still invoke it in the same way as we did before. So far, so good. A very powerful thing, and something that's very often used in combination with React, is object decomposition, which lets you decompose an object into its individual properties with just a single line of code. So given an object that consists of a name, an age, and an occupancy, I can decompose that into individual properties. And only the properties that I really want to have, I decompose. So the stuff that I don't care about, such as the occupancy, I don't decompose that, and that means I don't have access to it. So now I have a local variable text, which I can assign the value of the variable name, and that gives me Jane Doe. I can't do that with occupancy, as I did not decompose that one. So it's undefined, basically. The same holds for arrays. You can also decompose an array into its individual members. And you can make it really complicated and say, well, I have second and I have first, and then I have second, and that has the value 1. I would not advise to do so. I would advise to do it like this: first, comma, second. And then we see the value that exists at that index in the array. And again, I can't do third because there's no local variable third. If I would want to do that, I would first need to decompose the array into that element as well. I see there's somebody who was late. Questions are at the end, please. Thank you. So we have seen object decomposition and array decomposition. The other way around is also possible: object shorthand notation. Given I have a few local variables, such as name and person, I can compose an object out of those local variables, where the convention is that the property name equals the name of the local variable. So I have 2 local variables, name and age, and I can compose an object from those. And I can convert them to JSON so that you can see that it is indeed a complete object that has been created this way. Another very cool and useful feature is the fact that we can have string interpolation. So we can do stuff like this, this currency, let's say this value. And now I have some kind of a toString method, which is really a concatenation of values, but without doing string manipulation myself. I can declare in my code that I want to insert the variable at a certain place. And this also is very powerful and something that you can use quite a lot in combination with React. So with that out of the way, let's dive into how this JSX actually, what it actually is and how we can use it. What is JSX? Let's start with that. JSX is developed as a syntax extension to JavaScript, allowing you to use real XML values as JavaScript values. So please remember this. It's not an XML captured in a string of characters. It is real XML. That means you can do almost anything you can do with XML as well, including embedded expressions and the use of attributes. You can nest it. And a very cool thing, by the way, is the fact that React provides you with automatic XSS prevention, which is very powerful because there's a lot smaller risk of you accidentally injecting some malicious stuff in your web app. You can work around that if you're really sure what you're doing. The workaround for that is so complex that I always need to look it up. I can't even remember it from heart. So that's, I think, a good thing. There's a very small chance that you will do it accidentally, but given the precise syntax, that's not very likely. It doesn't work. It's not perfect, by the way. There are some limitations, and towards the end of the talk, I will give you a reference to a talk by Philippe de Rijk, who explains the limitations of React's XSS prevention. Now, the interesting thing is, I said already that JSX is an extension to JavaScript, a syntax extension, but browsers typically don't understand it. And that means that without doing anything, it will not run in your browser. Your browser will simply say it's invalid JavaScript. And that's why we need some kind of a transpilation step, which you could say is a mixture of transformation and compilation, to turn that JSX into valid JavaScript. And in the context of React, this transformation always happens from an XML tag to React.createElement, an invocation of React.createElement. So let's look at some JSX first. JSX consists of elements, XML elements, of course, which can be regular DOM elements. We recognize them by the fact that they start with a lowercase letter. So that is the convention. This is something that the browser already knows of. And if I instead insert some text there and I render that application, then you can see that it behaves almost exactly as I would expect. It just shows the text. As I said, elements can have attributes because that's also the same in XML. But sometimes their names are a little bit different than the HTML counterpart. Class, for instance, is a React keyword in reserved keyword in JavaScript. And that means that we can't have an attribute named class, but we have class name instead of that. And now we see that if we start typing blue, we are faced with a red text that reads blue. Very confusing, but I like a bit of confusion now and then. We can make it red. That's a lot easier and clearer. And the class name is just declared somewhere in a style sheet that I loaded. So that's just plain old CSS that we're using here. But you can also do different things with classes. For instance, the style, we can pass a string and say font face bold or font weight bold, but we can also pass an object here. This is very interesting. What's happening here? I'm not using quotes to give a value for the attribute. I'm using curly braces, and inside the curly braces, I put this object denoted by the curly braces again. So in fact, we have two pairs of curly braces here. And that declares the style of my element. And again, this does exactly as you would expect from reading the code. Even if you don't have any idea of how React works, it makes kind of sense to expect this behavior. Now, just as with XML, the same applies for JSX. We must have a single root node. An XML document that has two root nodes is invalid by definition, and it is the same for JSX because it is, after all, XML. So say that I would like to render two div elements. Well, in this case, it says adjacent JSX elements must be wrapped in an enclosed tag. Maybe you want a JSX fragment. That's something, by the way, that I really appreciate from React. Their error messages are typically pretty clear and pretty helpful in the sense of, hey, this is what you're doing wrong, and you probably want that. So there's two things I can do here. I can say react.fragment. I can put that around it, like so. React.fragment is basically an empty XML tag that does not result in any document object model element. It is just there to make it synthetically valid. Because this is quite a lot of typing to do. There's even a shorthand notation, which does work. But given that it is not per se valid XML, there's also the React.fragment variant. And finally, you can even put all of them in an array. Then, of course, you need a comma over there. And you can even render an array of elements. I think that React will secretly insert a React fragment around it. Otherwise, it still wouldn't work. So we've seen elements. The next thing that we need to know about is components. Components the first thing that you need to remember about them is that they start with a capital letter. So in this case, we have the greeter with a capital G. Very important. That tells the React runtime, hey, this greeter is something that you will not find in your underlying platform, which is the document object model in this case. This is something that you will need to resolve somewhere from the code base. So here I am rendering the greeter, and it means that the greeter component must be declared somewhere. Well, it's declared up here, so that's an easy one to resolve. As you can see, an arrow function, very compact. I'm taking some props, and I can use those props to render some XML from it. And we will see in a minute what we can do with these props. They are kind of like arguments to your component. That's a way to put data in them. Not to get it out, because as I said, it's all one-way data binding. So it's a way to put data in them. Let me show how that could be done. Props, nope, name is JCON, for instance. And now here I could say props.name. So what happens here? I'm passing an attribute, which is called name. That attribute ends up in this props object. It is an object with only one key. The key is called name, so I can read that. And to include expressions in JSX, I use the curly braces over here. So this is the very basic of what JSX can do for you. Let's dive into a bit more advanced use cases of JSX. The first thing, I already secretly gave it away to you, is the use of expressions in JSX. So using expressions, I can insert something that is not hard-coded. In this example, this piece of text is hard-coded, is always going to be the same, but inside these curly braces, I can put whatever I want. I can put a text over there. That's not the kind of text that I would expect, by the way, but that doesn't matter. Oh, I know how that happens. Never mind. I can put a variable in there, the answer to the question of life, for instance, and it's inserted into that text. I can also, since it's an expression, I can invoke a function there. And I can just say, well, invoke that function, use the return value of that function as an expression here and insert it into my document object model. And I could even insert literal values like a string or a number. That work, it's all the same. At the end of the day, it's all an expression in JavaScript, and the value of that expression is used here in the JSX. But I already mentioned that you can also use your props to do that. And this is basically the same thing that we did as before. I can use the props. I can read a value from it, and it works. The text is reflected into the web page. Remember about that object decomposition that we talked about before? You can use that to actually decompose your props. So rather than saying props over there and props.name, and well, this is what we saw, we can say decompose those props into a local variable called name. Then I don't need to say props.name over there, and I can immediately refer to the local variable named name with the value that I passed here as an attribute when I rendered the component. What we can also do inside JSX is embed control statements. So given, for instance, a property called happy and a value of true, I can run this statement. My component will actually run this statement, and it will say, well, if the value of happy is true, then I will render the clap hands component. Otherwise, I will render the dry tears component. And those are both defined up there with a very fitting text, clapping hands or drying tears. Now, if I would change that value, then the component will be re-rendered and it will choose a different path from the console statement. Another popular control statement that we can use is a loop. In this case, I'm declaring an array of ticker symbols. Both are famous Dutch companies, Heineken and Philips to be more precise. And let's imagine that I want to have a ticker list for them. What I do is I say I have a prop, which is called name, which is called symbols. And I'm going to map each element of it. It's an array, I know that. So I'm going to invoke the map method. And that means that for every element in the original symbols list, that one, I'm going to run that function. And that function is transforming the value into a new element. The element refers to the ticker component up there, which just prints out the symbol, nothing too special, but it shows that we can iterate over a list of items and then render something for that item in the list. And this is very powerful if you're building web applications that show a list of data, then this is a very common pattern to apply. So we've seen quite a lot already of what React does and how it works. Or well, how it works. Did we actually see how it works? I think we did not. We saw that it works, but we don't know yet how it works. How does React do its magic? That's what we're going to discuss next. And I believe this is very useful to know, because if you're running into troubles while building your web application with React, it really helps to understand what happens under the hood. What is the magic that you do not see immediately? If you understand that, it's so much easier to troubleshoot your application. So I've already talked about components and elements, how we can wire them together, nesting of elements, all far and all fine. But there's two places where the magic happens. And the first place where the magic happens is at build time. So when we actually build our React application, whether it is on our dev station or in a build pipeline, we need some kind of a tool that turns the XML that I talked about earlier, which is basically still a syntax expression, it's not valid JavaScript yet, into something that actually is valid JavaScript. In this case, it's going to be react.createElement. I'm wondering if I'm still sharing my screen. Can anybody confirm that, please, in the chat? Seems from what I see that I am. Thanks. Thanks a lot. There's usually a little thing on the top of the screen which shows you that you're sharing your screen, but that's gone somehow. Never mind. Thanks for confirming. So the first step of magic happens during the build. In the build, there's some kind of a tool. It's typically Babel, or if you're using TypeScript, it's TSC, which translates all those XML elements into a piece of code that basically reads React.createElement, first the name of the component, then the properties that it will receive, and finally, in this example, it's null, any child elements that might be there. That's the first piece of magic. Second piece of magic is runtime magic or behavior. That sounds a bit less obscure, right? So at runtime, we have a code base with a lot of React.createElement invocations written all over the place. That is going to be run by the JavaScript runtime environment, and React.createElement returns an object. And all those objects together form kind of a tree of components, a tree of user interface elements that we will consider for now the virtual document object model. It reflects what your application should look like, but it doesn't yet look like that, because that virtual DOM is then compared by React to the actual document object model, which will initially be empty because nothing happened yet. And it will then start to execute the necessary changes on the document object model. But those changes are computed in such a way that React will do an absolute minimum number of changes. And that's a good thing, because document object model APIs in most browsers are still relatively slow compared to other APIs that the browser offers. So if we can minimize the number of document object model changes that our application needs to do, the application will simply feel quicker and more responsive. And that's what our users probably expect. This process is called reconciliation. It basically synchronizes the virtual document object model with the actual DOM. And to do that, React uses two assumptions, and we need to be aware of those. The first assumption that React makes is that we have two elements. So one element as it is currently in the document object model, and another one which happened because our application re-rendered for some reason. Then if those two elements have a different type, whatever is under them in the tree will by definition be different. That allows React to do some optimizations. And the second one, which is probably even more important, is that if we have a list of elements, that we need to pass the key property to identify the child elements over a re-render. As you have already seen, as soon as I change a property, a component will re-render. So how will React know which elements are still the same and which are not? Let's dive in. Imagine we have this application, which is called some kind of a greeter again, because, well, I'm really not that creative with examples. I'm passing a name and a language. And depending on the language, I'm running a German greeter, a Dutch greeter, or an English greeter. Now, the assumption about the different type of element makes sure that as soon as I change NL into DE, the child element Dutch greeter is compared to what should be next up, the German greeter component. They are not the same. And React will just say, well, whatever is under the Dutch greeter is by now obsolete. I can just remove it. I don't have to traverse through that object model even further to decide whether or not to do more changes. I can just throw it away and render that part of the tree again. So the only difference here is the flag, because in German and in Dutch, we both say hello, which is pretty easy. But we could go for English for a second and we would see an English flag and we would say see hello, which is quite a difference. It's exactly one letter difference. But it shows what is happening. It will throw away the div, it will throw away the text elements under it. The second one is a bit more harder to understand, but it's also more important. So let's discuss this one as well. Here again, I have my list of ticker symbols. I added a few more companies this time, ASML and KLM, Dutch airline. And as you can see, I have a function here, which is random price, which will simulate some kind of a ticker price. And I have a shuffle component. I didn't include that in the listing because that's not the relevant part, what I want to focus on. What I want you to know is that as soon as I press this shuffle button, that shuffle component will actually reorder the ticker symbols. And if I would press it right now, let's do that. And let's remember, by the way, that for instance, Heya, which is Heineken, is 994 euros by now. I'm changing it. Heineken moved over there to the last point. Can't comment on that. And its price changed. Why did the price change? Because at this point, React is not able to say that the Heineken that was first in the list is the same as the Heineken that is last in the list. And as a consequence, it will drop the old Heineken. It will create a new Heineken. It will again invoke this random price method, and hence we have a different price. Put differently, React is not able to recognize somehow that this Heineken in the front is the same as the Heineken in the last, that the only thing that changed is actually the ordering of the array. How do we fix that? Well, that's where the key prop comes in. And I'm going to type it first and then explain you what it does. The key prop is a magical prop that we need to pass in such a scenario, which identifies each element over a re-render. And this shuffle button is actually triggering a re-render. So now if I would press the shuffle button, the symbols are shuffled, but React is able to somehow recognize that the Heineken that is now again first in row, 141 euros. Oh, it's still first in the row. That's not a good example. Now it's last in the row again, is the same one as that was a second ago, first in the row. And hence it will not re-render it, and it will not recalculate or re-simulate the price of that sticker. So this is a very important thing. And actually, if you do not pass the key prop, you will see a warning in your console saying, hey, you're iterating over a list, but you didn't pass the key prop. This is probably wrong. And there's two things that you need to remember about that key prop. The first one is that it must be stable. So every time I'm rendering the array, the key for a particular element must be the same. And the second one, which is kind of obvious maybe, is that it must be unique. No two elements in the array can have the same key, because then it wouldn't be a discriminator anymore. We couldn't distinguish two elements anymore. So stable first and unique second. So we've seen a lot of how React works now, really this time. Now it's time to look at how we can actually make a React application that works with the environment it lives in. Using react.useState, we can store a piece of information in memory. And if the application will re-render, this state is persisted. So that's a very important thing. In this case, there's nothing to see because we don't know how to change that state yet. To do that, we must know about events. Event handling in React works pretty much the same as in the document object model, except the event names are a little bit different. We use capitalization. Event handlers will always be functions and never strings. That's something you can do in plain JavaScript, but really you shouldn't. And an event handler is always bound to a component. Whereas in a vanilla browser environment, the event handler could live globally, which means you need to clean it up afterwards. But now it's done by the React environment. And the event that your event handler receives is actually a synthetic event made up by React to ensure it's browser agnostic. You never have to check for what browser you are using. So as an example, we have the counter again. It has state, perfect. And it has a function to increase the value and a function to decrease it. Let me implement it. +1, -1. Now, if I click the plus button or the minus button, it will invoke that callback, that increase. I don't use any data from the event, so I'm fine there. Don't need it. I will not use the event that actually comes in. And I will invoke the setCounter method. React.useState, which is called a React hook, by the way, if it starts with use, gives you two things. It gives you the actual value that's stored in the state, and it gives you a function to modify the state, the value. And using array decomposition again, I can actually get those two elements out of the array and make sure to have them as local variables in my code. Same thing for change callbacks, but in this case, we do need to use the event. So our update name method uses the event to get the actual value from the event target. And I can use the callback to do like this. I will create an alert as soon as the button is clicked. And indeed, it will give me an alert saying hello JCON, because it reads the state that was modified using the setName function. Last and most important thing to know in this part of the session is about data fetching and data manipulation over HTTP. As I said, React doesn't give you anything out of the box for this. So we actually need to write some code ourselves, for instance, using the fetch method that is present in all modern browsers nowadays. And then we can write a component that does something with it. So here, I'm going to build up a little piece of code to do some data fetching. I have a function running in the Oracle Cloud somewhere that generates some random stupid jokes. Fetch, as I said, is present in all modern browsers. I just invoke fetch, which gives me a promise. I check if the status of that promise signals that it is an okay response, and otherwise I will reject the promise. Then I parse the response data using response.json, and then finally I can extract data from the JSON. Let's see how that works. Here I have my component. It has a state which initially says that loading is true. As soon as I will click the button, as soon as I will load the event, an effect will fire, which will invoke the fetch random joke function. That will invoke the function that we just saw. And if that is done, we can say set state. And we can say loading is false. And the text of the joke, we just copy it in. And we put that in the state, component re-renders. And again, we can see the data that comes from the API. I'll run it once more so that you can see that it actually fetches another joke this time. Storing data in your browser is, again, not something that React offers from scratch. So we can use, for instance, local storage and session storage for that, which are both part of the web storage API, again, offered by all modern browsers nowadays. Important thing here to know is that the web storage API only stores and retrieves string values. So if you want to put something in there or retrieve something from it, you better use JSON stringify or JSON parse to turn that into an actual object. If you only need to store it for the duration of the session, you can stick with session storage. If it needs to persist, even over a browser shutdown or a tab closure, you should use local storage. So with a few minutes left, if I'm not mistaken, let's quickly run over how we can actually use all this to deliver this great app that you're planning to build. If you need to debug, and let's be honest, everybody needs to debug every now and then, your React application, I highly recommend to install the React developer tools. They are available for Firefox as well as for Chrome. And they basically allow you to inspect your application as a tree of React components rather than only the document object model. Of course, it also allows for debugging your components using the debugger, but that's something that you don't need the React developer tools for. For this particular view and also for the profiler, you do need those React developer tools. Debugging obviously supports things like source maps and stuff. So here we can actually debug TypeScript code inside the browser. Testing your components is done using Jest and the React testing library. And they allow you to run a component in an isolated environment without spinning up a browser, which is of course a very expensive step to do, and then make assertions about the output and the behavior of your component. So for instance, I can verify that if I am rendering a component that a particular text is visible on the screen. And I can even say, hey, if I have a button and it has a callback attached, let me inject a mock function there and then later verify that that function was indeed invoked when I clicked the button. And that firing the event is done using this line here where we say fire an event on a component that is visible in the screen, which has the link role. So finally, shipping your application, the best way I could recommend at this point is to use Create React. It's a set of libraries and test tools and build scripts that was gathered from a very broad community. And it makes sure that you don't need to spend your time on configuring Webpack or Babel or ESLint or the dozen of other tools that exist. Thanks for the reminder about the Q&A. We're almost there. And what CRA does is package all of that together and make sure that it all works together. That's a very good thing. I've tried to do it by hand, and that typically costs a lot of time. It gives you other goodies like live reloading and source maps, which is all very handy for building large-scale applications. You install it using npm-i globally create React app, and then it gives you another command which is create React app. You give it the name of the app, and there you go. It provides you with 3 commands that are most useful. Start to start your development work, build to create a minimized and tree shaken production build where every piece of code that's not necessary will be removed, and npm test so that you can actually run the tests that you wrote using Jest. So, as I said, we're almost at the end, and that is true. We are almost at the end. There's a couple of takeaways that I would like you to take with you after leaving this talk. If you are going to work with React for building applications, please use React app, create React app, as it will save you a lot of time in setting up your build. Start thinking of your application in components. Start seeing your application as a collection of components that work together. And start thinking in a declarative way, which means focus on what you want to see rather than how you want to achieve it. At the bottom, there's a couple of useful links, including the one to the talk by Philippe de Rijk about secure React applications. And having said that, there's time for a couple of questions. I'll keep an eye on the chat to see what questions you may have. You're welcome, Maarten. I'm glad you found it useful. Thanks to you as well, Volodymyr. I hope that is the correct pronunciation. But what kind of alternative do we have? I will keep that short, as you asked. Right now, I would say a popular alternative is Vue.js, which I believe does borrow some of the ideas of React, but it takes a different approach on some others. I think Angular is still also pretty well maintained and used a lot. Not Angular.js, by the way, but Angular, so without JS. But I do know about Angular that they take a different approach in the sense that they really give you this complete toolkit. That's just the one package, and it has everything that you need. And you can appreciate that for being complete, or you can say, well, I'd rather pick my own tools and mix and match it myself. That's really a matter of taste, I would say. As a Java, what pitfalls are there aside from the JSX syntax, and that more things need to be included via third-party libraries? JSX itself, pitfall, yeah, there are a few tricks that you need to be aware of. That's basically it. And I think I showed all the tricks that I am aware of in this talk, including how they go wrong if you don't do them. For me, thinking declaratively really was a thing that took some time. I did do some AngularJS development in the past, and there you write very imperative code. React works best when you use it in a declarative way. That's really, well, it's a mindset that you need to change a little bit. How does it perform across browsers? Issues? Could the virtual DOM update be incompatible for some browsers? Generally, the React team puts a lot of effort in making sure that your application will perform. The reconciliation algorithm is really sophisticated. I think they even rewrote it a couple of years ago because they had some design issues that were causing performance that they know they had to do better. And But generally speaking, performs quite well. They even provide you with a profiling environment so that you can see what component takes long or which component is re-rendering a lot of times. Can be very useful if your application starts lagging. But generally speaking, I haven't seen issues that change over browsers in React. So that I would say is a very good thing for a web application framework. What about runtime footprint in comparison to other frameworks? I honestly don't know. I have no data on that, so I don't think I'm really the person to comment on that part. Could we use string interpolation instead of JSX? Well, you can, but it's just a lot less powerful. You can, and that is very powerful, use string interpolation inside JSX. So where I showed you expressions, you can have a string expression which is actually built up using string interpolation. And that's a very convenient way to quickly introduce a snippet of text or a number somewhere without having to build that whole string up first. So I would rather say combine the power of the two and do not switch one for the other. Is it easier to learn than Angular? I found it a little bit harder to learn than Angular JS, but that's 10 years ago. So take it with a grain of salt. But once you get used to it, I found it a lot more productive, especially because Angular in version 1, they had this dreaded too many, what was it again? They had a particular kind of error message, which basically said, we have this two-way data binding and it happens too often and it doesn't stop. So now I'm killing it. And good luck finding out where it happened. That kind of stuff, you don't have it in React because it's one-way data binding. When a re-render occurs on a node in a tree, does it re-render also children or the update just a concern node? A re-render of a component will initially only re-render that component. But if re-rendering that component means passing different data to a child component, that component in itself will also re-render. If the data passed to child components is stable, does not change, then the child component will not re-render because its props are stable, they didn't change. All right, I think we are at the 50-minute mark. Thanks for your attention. I hope you will enjoy the remainder of JCON for today and hope to see you somewhere in real life, maybe, rather than this virtual talking to a screen and watching at a screen setup.
Thank you too, Mr. Mulders. Was a really interesting talk. We're now at the end of the session. The next session here will be at 4 p.m. So if you'd like, try joining the first stream for our keynote. Bye.